Hello students, and let us talk about a new chapter, trigonometry. Okay, it is very important chapter and also very useful one in our daily life and also future for college study also. Students, one thing I tell you, you have to thoroughly know about the basic things first. That is, in trigonometry, the ratios plays an important role. If you don't understand the meaning of these trigonometric ratios, you cannot study anything in the chapter coming days. That's why you have to learn these ratios, trigonometric ratios properly. You should know the meaning and its actual meaning, actual definition, what they are. Okay, let us go for that. First we shall discuss about the trigonometric ratios. What is trigonometry and trigonometric ratios? So that is what the beginning of this one. You should learn this one. See here, the word itself says trigonometry, no? Trigonometry means three, tri means three, gona, sides, metry, it is a measurement. Means it is a branch of mathematics which deals with the study of measurement of three angles and three sides of a triangle here. Okay, trigonometry is it is a branch of maths which deals with the study of measurement of three angles and three sides of triangle. In similar triangles, we took the ratios of the corresponding sides of two similar triangles, is it not? Here, it is very, what is the advantage of this trigonometry means, if we know the angle, we can calculate the side. It will give the relationship between angle and sides of a single triangle. In the previous classes, if we know the sides, two sides, we can calculate another side. No, here does it mean if we know one angle and one side, we can calculate other two sides easily. This is what the advantage of this trigonometry. Okay, so here we are going to talk about only the right angle triangle. Because any triangle can be converted into a right angle triangle by drawing a perpendicular from the vertex, any vertex to the opposite base. Okay, so that's why. Let us go for the discussion of these trigonometric ratios, actually what they are. So these trigonometric ratios are the ratios of the sides of a right angle triangle. Okay, so there are three sides and three angles will be there in right angle triangle. Among them one is right angle, so other two are acute angles. Okay, two acute angles will be there, one right angle will be there, so that's why it is a right angle triangle, is it not? Three sides will be there. Correspondingly, if we took the ratios of the sides, we get three sides ratios, that is height by hypotenuse, base by hypotenuse, again height by base, like that. Okay, so similarly, if we took the reciprocal of those ratios, we are going to get the other three ratios. Those are called trigonometric ratios. So trigonometric ratios means basically these ratios are the ratios of sides of a that is sides of the right angle triangle taken in order here. Okay, so let us go for the first, that is, let us consider a triangle ABC, a right angle triangle ABC, where B is equal to 90 degree, and let me take, for my convenience, I am going to take one of the acute angle C here. Let me treat that as theta. Theta is a small angle, acute angle, small acute angle. Okay, so with respect to C, I am going to define three sides here. In trigonometry, you should know the names of the sides of this triangle. So that means the opposite to the angle C, that is theta, we consider acute angle, is called as opposite side. So the side adjacent to the corresponding angle, that is small angle theta, is called as adjacent side. And as we know, the biggest side in a right angle triangle means the side opposite to right angle is called as hypotenuse. Okay, these are the three sides. We have to know the names of the sides of this right angle triangle. Based on this, we shall take the ratios of the sides. You know what is ratio? Okay, ratios of the sides. We get the trigonometric ratios. So how you see, with respect to angle C, I am taking the ratios here, not with the another angle A. So that will be, what will be the measure of A? That actually will be 90 minus A, 90 minus theta. So because A plus C gives 90 degree, no? Because B is 90. Therefore, another angle A will be 90 minus theta will be there. I am not talking about that angle, but basically the considered angle is C here, that is theta. Okay. Now with respect to that angle C, that is theta, acute angle, I am going to taking the ratios here. Observe carefully. I am taking the sides, ratios of the sides of this right angle triangle, that is opposite side by hypotenuse. It is one of the ratio. First ratio is opposite side to the hypotenuse. Therefore, it is similar with respect to this triangle. This is AB by AC now. So this ratio is treated as sine theta, sine of angle theta, sine of angle theta is treated, that is defined as opposite side by hypotenuse, that is AB by AC. Similarly, if we took this adjacent side by hypotenuse, the ratio of the sides adjacent side to the hypotenuse, that is BC by AC, is named as cos theta, cos of angle theta. It is the second ratio of trigonometry. Okay, so the third ratio is, you see, opposite side by adjacent side. This is another ratio. If you go on taking the ratios of this right angle triangle, we are getting the trigonometric ratios. We are naming those ratios with different names here. That you have to learn. Okay. So the ratio opposite side to adjacent side is, that is AB by BC now. So that is treated as tan theta, tan of angle, tangent of the angle theta here, because hypotenuse is lying on the two bases, two sides, no, that's why it is called as tangent to those two sides, tangent of angle theta. I think you clear about these three. Okay, so that is sin theta is opposite side by hypotenuse, cos theta is adjacent side by hypotenuse, so tan theta is opposite side by adjacent side. If you took the reciprocal of these ratios, that is sides, that means hypotenuse by opposite, that is also a ratio, no? Hypotenuse by opposite. So that is hypotenuse by opposite. The tan theta is also taken as cos by sine, the ratios of sine to cos. You see here, if I took that opposite by hypotenuse, that by the adjacent by hypotenuse will get cancelled, opposite by adjacent we get, no, that is AB by AC by BC by AC. If you took AC you will get cancelled, AB by BC we get. Therefore the tan theta is also taken as ratios of sine to cos. Okay, sine theta to cos theta. So now we shall take the reciprocal ratios, reciprocal relations. So that is hypotenuse by opposite side. That is also one of the ratio, no? These are inverse of the reciprocal of these sine, cos, tan here I am taking. That is hypotenuse by opposite side. That means AC by AB is treated as cosecant theta. What is the name given to the inverse, that is reciprocal of sine, is cosecant theta. This is also taken as 1 by sine. These remaining three ratios are called reciprocal ratios. Okay, 1 by sine theta. So again, if we took hypotenuse by adjacent side, hypotenuse by adjacent side, that is BC by AC, AC by BC, AC by BC, this is treated as secant of angle theta, secant of angle theta. So that is also taken as 1 by cos theta. 1 by cos, reciprocal of cos is secant here. You have to remember these 6 trigonometric ratios. Once again I am telling you. The last ratio is, you see, the adjacent by opposite. That is actually the reciprocal of tan theta, adjacent side by opposite side, that is BC by AB, is treated as the cot theta. So that is cotangent of angle theta, or reciprocal of tan is called as cot theta, or we can also define that as cos by sine. Is it inverse of, that is inverted ratio of tan theta, that is cos theta by sine theta is treated as cot theta. These six ratios are called as trigonometric ratios. Okay, sine, cos, tan, cosecant, secant, and cot. So you have to know these ratios. This is the basic one. If you know this one, that is ratios, naming the ratios of the sides of right angle triangle, trigonometry will be very easy. So this is becoming separate branch in the future. Okay, that's why I'm telling you, and also it will plays an important role in the mathematics as well as in our daily life. So that means as we discuss, reciprocal trigonometric ratios are cosecant, secant, and cotangent. So they are 1 by sine is cosecant, 1 by cos is secant, 1 by tan is cot. Now we shall go for the second component. That is, we shall apply those things here by taking some examples to better understanding sake. Okay. Write the trigonometric ratios with respect to angle, acute angle C here. If in triangle ABC, BC is equal to 4 centimeter and AC is equal to 5 centimeter. So here BC and AC, two sides are given. To take the ratios of trigonometry, we need the length of the sides of right angle triangle. No, one more side, side of the length of the side we needed AB. First you calculate that one using the Pythagoras theorem, no? So using that you calculate the length of AB. So in triangle ABC, B is 90 degree. Of course, by Pythagoras theorem, as we know that square and the hypotenuse is equal to sum of the squares on other two sides. AB square plus BC square is equal to AC square, no? So therefore AB square plus 4 square is equal to 5 square. 25 minus 16 is 9. Square root of 9 is 3 centimeter is the length of AB. Now we know the length of all the sides. Now we can define the trigonometric ratios easily, is it not? So as we know that sine theta, trigonometric respective trigonometric ratios are given by sine C. Sine of angle, acute angle C is given by opposite by hypotenuse, means 3 by 5. Opposite side by hypotenuse is AB by AC, that is 3 by 5 we can say. Similarly, cos C is given by 4 by 5. No, that is adjacent side by hypotenuse, that is BC by AC is 4 by 5. We can write directly again. Tan, as we know, that is opposite to adjacent. So AB by BC is 3 by 4. You see how we are getting the ratios of the sides. These are the sine, cos, tan values of this respective triangle ABC here. So what about the cosecant theta? Is a reciprocal of sine, no? Cosecant C is given by, that is hypotenuse by opposite, means here AC by BC is 5 by 3. Similarly, that is secant C is a reciprocal of cos, that is hypotenuse by adjacent side, BC by AC, or AC by BC is given by, that is 5 by 4 here. Okay, 5 by 4. So the last one is cot C. Cotangent angle C is given by, that is 4 by 3 now, that is BC by AB, adjacent side by hypotenuse, opposite side is given by BC by AB is 4 by 3 here. So these, in this way we are going to apply the trigonometric ratios. We can calculate and see. Okay, so for your homework sake, you take this triangle and write all the trigonometric ratios. Okay, let us go for one more. If angle is given, what we shall do? You see here, if cos A is equal to 4 by 5, then find the values of sin A, tan A, cosecant A, secant A, and cot A. Their sides are given, we took here also sides are given, but it is defined in the trigonometric ratio. We are going to represent trigonometric ratio one with respect to other ratios here. Okay, so that's a one ratio is given, we have to write remaining ratios here. Cos A is given, again you can calculate the angle BC, side BC, by Pythagoras theorem. 4 square plus BC square is equal to 5 square, means again 25 minus 16 is square root of 9. BC is given by 3 centimeter. Okay, 3 centimeter we get, that is BC as 3 centimeter. By knowing the sides, let us define other ratios here. That is sin A 3 by 5 directly opposite by hypotenuse, tan A 3 by 4 opposite to adjacent, cosecant A hypotenuse by that is opposite side, that is reciprocal of sin is cosecant, 1 by sin 5 by 3, secant A opposite of that is reciprocal of cos is given already 4 by 5, this is 5 by 4. So cot A is reciprocal of tan 4 by 3. In this way we can define the trigonometric ratios. Okay, so for your homework you can calculate by taking sin. If sin A is equal to 1 by 2, then find the values of cos A, tan A, cosecant A, secant A and cot A. One of these you will given in your examination by giving one. He is going to ask only one ratio for 1 mark, he may be. Okay, so you have to learn this one. So this is what enough trigonometric ratios today's discussion. In the coming days we shall go for solving some problems based on this, and also we shall know what are these standard angles. Okay, how to calculate the height and distances using trigonometry, and also some of the trigonometric identities, and also complementary angles with related to trigonometry. So learn these things carefully, students. You have to know this thoroughly, otherwise you cannot understand further coming chapter, that is items in this trigonometry. That's why I am telling you once again, learn this thoroughly and get ready for the next items in this trigonometry. Thank you, students.